Okay, I'd like to look at example 2a on page 82 of your workbook together here. Okay, and let's read this problem together. This is a problem of a type that we've done before. Okay, it would like us to take the linear transformation from R3 to V that they're giving us and to decide whether it's invertible, and if it is, to find a formula for the inverse. Okay, you might remember we had a specific strategy for a problem like this. We started by finding a matrix for the linear transformation and using the fact that we know how to find the inverse of a matrix to help us find a formula for the inverse of the actual transformation. Okay, so if we want to find the matrix of T, that means we need to make a choice of basis for our domain and for our codomain. Generally, you try to choose the easiest basis that you can. So how about if for R3 we choose the standard basis? Okay, and you might remember we had a basis for V, that is the set of symmetric 2x2 matrices that we've used a couple of times. Okay, and it looked like this. All right, so let's stick with that familiar basis that we've used for V. Okay, and finding a matrix for a linear transformation, we know that process. It's about taking the basis vectors for beta, our input basis, substituting those in one at a time, and just seeing what we get out. All right, so we'll start with T of 1, 0, 0. Okay, so we need to plug in A equals 1 and B and C are both 0. You can look at our formula up here, and if you substitute in the A, B, and the C, you're going to get an output of 1, 1, 1, 0, it looks like. All right, and we need to take that output matrix and write it as a linear combination of our gamma basis. Okay, and since our gamma basis is pretty nice, it's got some zeros, that's not too difficult to do. Okay, I'm just going to write this out, and you can double check my calculations. Okay, and there it is. And then we just need to repeat that calculation for the other two input basis vectors. Okay, so T of 0, 1, 0, now B is 1, and A and C are 0. If you look back up at our formula for T, okay, and just do the arithmetic, here's what you're going to wind up with for an output. Okay, and then do the same thing for 0, 0, 1. Okay, there, C is going to be 1, and so we're going to get an output that looks like 2, 2, 2, 1. Okay, we just need to take those two matrices and express both of those as linear combinations of gamma. Okay, and I'm just going to write out those calculations. You can double check my arithmetic. Okay, and remember that writing down the matrix is really about looking at the coefficients. All right, so I'm just going to circle those. Those are the entries that are going to wind up in our matrix for this transformation T. All right, so far what we know then is that the matrix of T, taking us from beta coordinates to gamma coordinates, would look like our first column from the calculations above looks like 1, 1, 0. Okay, second column is 0, 1, negative 2. And then finally 2, 2, 1. Okay, but here's where we remember that what we're really interested in is a formula for the inverse of T. Okay, what we have in front of us is a formula for the matrix of the original transformation T, so we'd like to find the inverse of this matrix. All right, and just to review that process, it involved starting with the matrix that we just found. Okay, and augmenting an identity matrix. Okay, and if we do row operations, you can either do these by hand or on your calculator. The idea is to take this matrix over here to the left and to transform it into the identity matrix, and then what ends up on the right should be our inverse. Okay, so after either doing those row operations or using a calculator to do those, here's what you'll end up with. Okay, and this matrix over here to the right should be the inverse of the matrix that we started with, and so far what we know is that the matrix of T inverse going from gamma coordinates to beta coordinates should look like this. Okay, so we've cleared the first major hurdle in the problem, but they want us to go a little bit farther than finding just a matrix for the inverse transformation. We'd like an actual formula for the inverse transformation. Okay, that forces us to remember what it is that a matrix tells us about a linear transformation. Okay, so let's get ourselves a little bit more space here. Okay, and the idea of a matrix, again, is it just takes us from one set of coordinates to another. Okay, so if we just take this matrix for the inverse that we just found, okay, and just imagine taking kind of an arbitrary set of coordinates here. I'll call them A, B, and C. If we do that multiplication, it's going to give us another set of coordinates. Okay, so I'm just going to literally multiply this matrix by this vector. You can double check my calculations. Okay, there's the first row times the first column, and then second row gives us a minus A plus B plus a 0C, and then finally negative 2A plus 2B plus C. Okay, what does all of this mean? Well, again, remember, the ABC over on the left represents alpha coordinates of an input. Okay, and over here, this represents beta coordinates of our output. Okay, so we have to kind of remind ourselves which basis is which here. Okay, gamma was the basis for V, the set of symmetric matrices. So when we see A, B, and C, we have to think of those as being numbers that go in front of our basis for V one at a time. What that gives us is T inverse of A, B, B, C. Okay, again, the A, B, B, C that you see here comes from just taking the A, B, and the C up here. Okay, and just putting those in front of our basis vectors for for gamma one at a time. Okay, and then what comes out on the other side of the transformation we get by looking at our other coordinates. Okay, the beta coordinates over on the right-hand side. So this one, this one, and that one. Okay, we need to take those and think of those as being coordinates in front of our basis for beta. That's going to give us something that looks like this. Okay, for this last part of the problem, it might help you to look back at some of the examples that we did previously. Okay, it's been a while, but it's something that we did before. Okay, and so what we have just found is the formula that they're asking us for. So T is invertible, and we just found a formula for its inverse.